Hello everyone, thanks for joining. Just give me some time and I will turn on the live streaming for this webinar, and this will be live streamed on all our platforms wherever SingleStore is present. Or like anything in general, right? So we have Akmal to take care of the questions, and we have Dr. Tom, who's all right. So I think the live streaming is in place now. All right. So hey, thanks everyone for joining, and I see more people joining in. So I will be so basically. Hi, I'm Yukti, and one of my main jobs here at SingleStore is to organize these weekly AI webinars. And today we are fortunate enough to have a webinar with Professor Tom. He is from University of Colorado and Boulder. Thanks for joining, sir. And this webinar is called "Building a Vector Database in Excel." And this will, I think, Tom, this will be like again a AI by hand session, right? Oh, that sounds awesome. So basically, professor is going to teach us coding with like, like written. So that would be really fun. So stay tuned for that. And if you have any questions, we have a Zoom Q&A button, which is present at the bottom of your console, and feel free to use it whenever you want to have a discussion. There's something that you would like to point out. So we don't exactly entertain raising hands because that sometimes disrupts the session. So if there's anything that you would want us to get to, use that button and we can have a interactive session. I will be posting the resources to everything in the chat, so feel free to check that out. And Mr. Tom, please take it away. And thank you so much, everyone, for joining.
Yukti, I can just show a couple of slides and then hand over to
Oh,
Tom.
awesome. Yeah, absolutely. Please,
Yeah.
please.
So as Yukti was saying, so we are very privileged. Let me just see. So we have um, Tom here, who's become a regular part of the furniture. We're grateful to him for his time and his efforts here. So I'll just show you two slides, okay? Just about SingleStore, and that's it. And then I'll hand over to Tom. So the first slide is this. Essentially, SingleStore started off as a company focusing on OLTP and in memory, and that was way back in 2011 here, as you can see. And at that time, it used to be called MemSQL. Okay, so the mem kind of gives it away a little bit in terms of in-memory processing. Subsequently, over time, added columnar store, okay, for analytics. And so it kind of made sense that you don't want to call yourself MemSQL anymore, because you're doing more than just in-memory processing. And so some years later, rebranded to SingleStore. And so the idea here is that you have one product with a single table type that can handle both types of processing. Okay, so that's both OLTP and OLAP. And other than that, some key milestones shown here. So vectors has support for that since 2017, 2018 timeframe. So it's been quite some time. So it's mature, battle tested. Originally, I think it was requested by one of our customers in the financial vertical. And so over time, as you can see, both the revenue has grown. So this was kind of an inflection point way back here. Seems to have grown steeply there. So we are a $100 million plus ARR, annual recurring revenue company, and over 350 global customers. I think that number is approaching something like 400 now. So we really need to update the slides here. So there's the key sort of milestones there. And then architecturally, this is kind of a nice high-level view, if you like, 30,000-foot view, I think they sometimes call it. So we have this concept of universal storage, okay, with this single table type, as I mentioned. And we integrate with a wide range of technologies, and this is just a small sample. So if you're working with Kafka, for example, or Apache Spark, and actually just a little bit earlier today, I was talking to Yukti about the sort of plans for events that we may have, coming up over the next few weeks and months. And these are topics, integration with Kafka, integration with Spark. We'll be looking at those as well. If you have data in other forms as well, maybe Hadoop, HDFS, or legacy systems, we can ingest those as well. And you see this kind of animation in the middle here, which is really showing this concept of pipelines. Again, very useful feature, ingest data at scale into SingleStore in parallel. We do work on all three major cloud platforms. Okay, it's AWS, Google Cloud, Microsoft Azure. You can run us on-prem as well. There is a Docker container as well. But seriously, the quickest and easiest way to use the technology is just to go to portal.singlestore.com, sign up. Okay, it's 1 or 2 minutes of your time, no more than that. And when you log in, automatically you have some resources provisioned for you. So you have a workspace and a database, and that's part of the free tier. And literally straight away, you can hit the ground running. You can start coding in SQL, build Python notebooks, and so on. Very easy to get started. Key things, well, it is a relational database. That's where its roots are, but we do support geospatial. Okay, full text search. Again, major announcement about that, version 2 using JLucine coming up very soon. JSON support, that's been there for quite some time. Time series, okay, if you're working with that. And of course, vectors, which has been there for ages compared to some of our competitors. Although earlier this year, way back in January sort of timeframe, we did announce some improvements in this space, okay, a dedicated vector type, as well as ANN indexing and so forth. I mean, it's all covered in the documentation. And finally, just to wrap up then, so real-time decisions, AI apps, dynamic experiences, integration with a wide range of dashboard technologies as well. So if you use Tableau, for example, or equivalent, I'm a big fan of Metabase. It's just jar file, you download it. You need to have Java installed locally, but literally within about 2-3 minutes, you can be creating pie charts, bar graphs, and so on, and with a secure connection to wherever SingleStore is running, whether that's locally or in the cloud. Very, very useful in terms of getting stuff up and running very quickly. And sometimes for proof of concept, that's quite useful as well, because you can show results immediately. Machine learning, we've covered a lot of in the past. And of course, Tom is going to focus on some aspects of vectors and their applicability. But he is going to use Excel today. Okay, so this is unique. So I've not come across this before. So I'm looking forward to Tom's presentation as well. And you will see a little bit of magic today. Okay, so there's a quote from one of my favorite authors. Any sufficiently advanced technology is indistinguishable from magic. And with that, I will stop there and stop sharing. And I will hand over to Tom, who will take it away.
All right, thank you for introduction and having me here back to this webinar series. I've been totally enjoying this. And so I'm trying something new I have not done before, but I promise you is I practiced a few times, but it's the first time doing this live. And I hope it will work. So I'm going to share my screen and just bear with me while I'm turning this on. And hopefully this is the whole database in Excel that I built and I shared it out right before this webinar to give you a preview. And today what I'd like to attempt is to go from this blank spreadsheet and to reconstruct that vector database, and while taking you through step by step and to provide my commentary and explain and to talk like a professor. Hope you can learn something from me today. All right. Okay. But I realized that to make my life easier and also stay true to the philosophy of AI by hand, I actually sketched out the whole thing I'm going to code today and by hand. So I'm gonna take you through the first step of training the embedding for each word, and then if we have a text that I would like to chunk them into individual pieces, and then I would be able to take each chunk and then fit them into a sentence transformer. In this case, I have three words in each chunk. Those are marked by blue, the green. And then if you scroll down, like each chunk going to be embedded into this embedding vector, which is the vertical column of this embedding vector, just one column. And when we have enough of this, and then we'll just end, which our destination today is to pull them all into a vector database. And down here looks like a table and with different chunks and embedding. And then eventually we'll be able to support application, which is to take a query, which is also a chunk, 3 word in this case, and then get a query embedding. I'll be able to compute similarity using cosine metric and be able to find eventually get the top K in this case too. All right, so this is the roadmap of what I like to accomplish, and hopefully I will be successful. And but since it's live, you will see me making mistakes throughout, and so and then it's just then to all can learn from my mistake as well. All right. So the first step I'd like to be able to do is to tell you what embedding means. So I like to get these things called the word embedding. They're all in this orange stripe over here. And so over here, if you can see my mouse over here, so I turn down the cursor location. You can see where my cursor is at. And so I believe nobody's complaining about a resolution. You're seeing this quite well, right? Okay. And so before I go further, I've shared this exactly this blank Excel sheet on the website, and the website is by-hand.ai, by-hand.ai. So it should be on the front page, and you could download this version. If you like to follow along, you can, or you like to skip ahead to see what's to come, you could. I encourage you to download this Excel sheet. You can open it up yourself too. All right, and so in this I also share the code that I is intended to build. Anyway, going back to train embedding, my goal for this step is for this I want to have a list of words and sort it. And each word I like to have 1, 2, 3, 4, 5, 5 number to represent the word, and each word will have the 5 number over here. Okay, so that's my goal. And so this step is a bit more warm up. You are not familiar. You're probably very familiar with Excel already, but so this is warm up before we get harder. So first, uh, I'm going to copy this long text into this box. So to train embedding, typically we have a corpus of a lot of text, and then today in this tour example, we're gonna just copy and paste this. And because Christmas season is coming, so I just found this write up some random text about Christmas. Christmas brings joy, love, and warmth. Families gather, sharing gifts, laughter, and stories by cozy fires, and so on and so forth. And then to use this text to train the embedding, so this is a very simple natural language processing 101. And again, it's a warm up, but just I'd like to familiar with just to show you and practice coding a little bit in Excel. So for first step, I'd like to break it down into individual tokens. Instead of just one really long string, I want to break down the token. In Excel, I can use this text split, which is the function I will use. And I'll go here and select this. And then I would like to not delete, not breaking down into columns. I like to breaking down into rows. So I skip this, and there's a row delimiter. So I'll use a space. So this is gonna give me a bunch of the same words. I mean, the individual word in my training text into a column. So this one. And I did claim that a little bit. If you notice that, and here, laughter. Can you see this laughter? Laughter has a comma, and they'll have some kind of period. I want to remove them so that I just only get a word. Okay, and then so for instance, for twinkle, I want to get twinkle, just twinkle, not twinkle, comma. All right, so in Excel, it doesn't have a very good function to do that, but the way I like to use is I use substitute. So I can use substitute and select this one, and I want substitute all the period to nothing. So they'll get me do this. If I test this feature, test this, I copy this and go into this, where do I have period? Here. Warms. So you can see that warms period become warms. So clean that a little bit. And then if I can do more is I want to also clean up. If I copy over here to twinkle, it doesn't quite work. I have to, substitute doesn't take more than one word, so I can do this nested substitution again. So, and I will do this time. I want to substitute all my comma with like nothing. So this is will remove comma and also period. So you can imagine that somebody will write lots of this text processing routine in order to do cleaned up. Another thing I can do is that instead of if I use this one for the first word Christmas, maybe I like this to be all lowercase, so I add lower at the very end. Okay, so this is still very Excel 101 that you have probably done this before. Nothing too new about this, but it's more like review. Okay, now I get this Christmas. Lower warms is periods is removed and period commas are removed. You can do more like you can remove S to do the same, but then it's for this today. We're not. This is not about NLP in steps. So I think this is good enough for me for a clean step. Then I'm going to copy and just paste this, and then okay, work, and then then I can paste to the whole thing now, whole column, and go all the way down, all the way down. Oops, too much. Let's go back. That's not what I want to do. Let's just say it's live. Copy over here. Do okay. I copy more, and then I'll copy more to all the way to the bottom. Okay, here to this one. This is where I want to stop. Okay, so now I have all of my token cleaned up. So, and then there's some words that kind of repeating themselves multiple times, but I want to get a unique set of words. So this in turns out it's kind of easy to do in Excel because we can use unique, which is a function, building function. And then I just select this array. Now this time I can go all the way to bottom as the result. So it turns out in this text, it's only a few words that repeat itself. So now I've got a shorter word token. And then eventually I want to sort them. So easier for me to see what words are available. I sort this, select again, select to the bottom. And then this is my sorted tokens. But so this is the vocabulary I'm learning from my training text. And in practice, this training text would be like gazillion uh, documents, gigabytes worth of text. But you still follow the similar process of breaking, tokenizing it into tokens and clean it up and normalize them, removing different stems. Sometimes really long work got chopped into different even smaller tokens that can be done before. All right. So these are text, and embedding this idea is that maybe there's a way we can represent each word into vector. So the first decision we make is that what is the dimensionality of this vector? So say 5. In this case, I just use 5. So I have 1, 2, 3, 4, 5 space reserved. So I can type something like 0 0.1, 0 0.2, 0 0.1, some random number to begin, and before I start some learning process. And for R, I can do 1.2, 0.1. So just studies, we can start with some kind of random number. And in the machine learning algorithm, there are algorithms for training this. And from okay, and so one way I can do this is I can do using the random function, and then I just copy my function to the entire block that I need. So this is my there will be 1, 2, 3, 4, 5. Okay, so these are all the different numbers I have here. It's kind of hard to see. Maybe it is not that hard to see. And okay, so this is I have a word embedding. These are random number. I haven't really put in learning yet. And so, and in Excel, if you use a random number, one thing that I kind of found annoying is that if I say I put another, add it somewhere else, all these numbers change. So I like the behavior to stop, so I could just comfortably work on it. So the trick I'd like to use for myself is that I will just copy the whole number, and then I go back up, and I'll paste over itself, but I will paste them using spatial pasting. I only paste the values, not formulas anymore. I press V, press values, and OK. So now this number will fix to the value instead of formula. So if I do changes stuff, doesn't change anymore. Now we initialize word embedding with some random number, and the learning process is kind of like this in this way. So for instance, there are some you were trying to find words that are similar in meaning. For instance, share, as they say, smiles is and laughter. There's a smile here, and we have laughter up above. And then you have a training examples, probably like, oh, laughter and smile, they tend to appear in the same sentence. You see it over again. Every time you see it appear in the same sentence, we could say, oh, well, I was just gonna say 0.5 to 0.9, and then I'll add smile to 0.9 again, so they are kind of becoming similar, a bit more similar. And they can find another two word, love maybe love in memory, should that be similar? Maybe they should. But now just change the number to something closer to each other. Okay. And love is anything that opposite. If say Santa, and maybe it's not a good idea. Say shine. I don't have a opposite. Just say just pick any two words. I say love, love, and what else? Love and kept. They are not supposed to be similar, but they are just two different words. I could just purposely make one minus one. Oh, sorry, not here. Where's my love? Here, one, make it one, but make it another one opposite, say minus one to put them further away. So you keep repeating this process. So that it's like an intuition behind training this word embedding. That's usually done by large companies like Google, and they'll share on Hugging Face. You can just use this word embedding. But I just want to give you some intuition. That's how word embedding are trained. It's just very simple process. Training, embedding. Take a large corpus, training text, tokenize them, clean that up, got a whole bunch of words that become your vocabulary. And in here, I have about 200 words, maybe 100 words. But in reality, in practice, you could have 10,000 words or 60,000 words. If you're multilingual vocabulary, you have 200,000 words and so on. And you choose embedding size. We have 5 here, but in practice, it could be 512. It tends not to be super big. 512 is pretty common here. So that's what we have here now. Now we have this word embedding. Then we have now we talk about application. When I want to use this embedding to to index a text that I actually do have. So this new text coming from me. Okay. So now I know I have a vocabulary that's from the Christmas. I have some kind of shorter Christmas text that's my text. Christmas bring joy, love, and warmth. Just actually, it turns out it's a shorter version of the same text. Just pretending this is my text, I want to index now into my own database. And then we'll follow a similar process of tokenizing and cleaning it up. So I'm gonna copy my tokenizing function over here. It doesn't work like that because it was selecting the wrong cell. So I gotta move this over to my new text block. So now it tokenized them into this. It's a shorter text, so fewer tokens. And I can also then use cleaned up. Okay. And then I copy my clean text and then copy over. I copy a formula and copy over all my tokens locations. So that's how now I cleaned that all the periods and commas are removed and everything is lowercase. And you might notice that I skip sorting and unique because now in the application in indexing, it's okay. Actually, I do care about whether words repeat themselves. I'm not trying to learn a unique vocabulary here. I just use them because I want to index them. I want to put them into a vector embedding sentence transformer, which we're going to talk about. They will transform a bunch of words or vector embedding into a single vector, and I can put into the vector database here. So that's what I want to do next. So and because usually when you take a transformer kind of encoder, so there are some limit into the context length, how many tokens you can feed. For instance, 5,000 tokens or 10,000 tokens. In my very simple sentence transformer, is the limit is 3 tokens, very small, but there's a but it's something I can handle. 3 tokens. So because of that, I have to chuck my input text into the unit of 3 instead, or fewer than 3 too. But in this case, I have a parameter for my chunking, which is my chunk size is 3 that matches the context window for my sentence transformer size. And then also have an overlap, meaning my each chunk I like to have some overlap. For instance, I'm gonna free my pen now finally. So if I have chunk is like Christmas, bring joy is one chunk. If I overlay, it means my joy, love, and N is another chunk. We can look at in this here. This is my first chunk, and my second chunk is not there. Okay, my second chunk will be joy, love, N. So that's what I like to accomplish, and I have the function called chunk, and I'll say select this cleaned up set of token words. And then my first parameter is chunk size is 3, overlay is 1, and voila, I'm gonna get this arranged in this case. You can play with this function a little bit. So if I have a chunk size equals 0, overlap, and you can see that this Christmas bring joy is without overlap of 1. But when have overlap of 0, is Christmas bring joy, but love and warmth, there's no overlap. Let's go back to my overlay of 1 here. Chunk size is equals 1. So that's my chunking. I break down a list of tokens, a sequence of tokens into a groups of 3. Now I have 6 of this, and each one have a unique ID. I just number ID, give the ID 1 all the way to now I have 6 chunks in this short text. 6 chunks over here. Okay, so this is chunking. Now it's getting to we finish warm up. I'm going to get into the hardest part, which is of this today's lecture, which is to tell you about a little bit about sentence transformer, and so hopefully I able to explain this math just in a simple enough for you to see. So the overall, my goal is to now have a chunk of text. For instance, what's my first chunk? Is Christmas brings joy, and so I could just type them, but I'm lazy, so I gotta just use this equal sign to say, oh, this is the same as this 3 cells. Okay, can you see this? All right. So I have Christmas brings joy here, and then I like to do is to look up this embedding from my vocabulary. Where can I find this embedding from vocabulary? One way I can do is that I go to the left here. This is my vocabulary. Okay. So Christmas is which word is Christmas? I go down my vocabulary and find the word Christmas here. So and then this is my embedding here. So I can copy this, or maybe not copy this. I want to actually select this. So I select this. I will select this embedding from Christmas. So I'll select here, but it doesn't work. It goes the wrong direction. How can we fix this? So we can use this function called transpose. So I basically want to transpose then into my column vector. So it's what happened here. Okay, so I just did it for one word Christmas. And we can repeat the same process of brings and joy. So I have 3 of this. Okay, just try to repeat this process. Just do one more time, just as a review if you didn't follow me. So I'm gonna go find brains. That's why I sorted them. It's easier to find brains right here. And I select this. Okay, now I have this. And repeat the same process. It's in the wrong orientation. So I'm gonna do is I transpose to this, transpose, transpose. Okay, I have 2 of this. Now I can do another one, but I'm gonna write a formula now. Instead of doing this by hand. But the overall goal is that whatever sentence transformer gonna go through, the goal is to have 3 vertical orange stripes, which represents 3 column vector. Each one is 5 dimensions. Series of transformation. Somehow it became 1 vector with a more dimension, higher dimension space. 1, 2, 3, 4, 5, 6, 7, 8. I decided that I would like to use 8 dimension for my embedding vector. So I gonna go next is gonna go through the transformation space, and it's a bit review or explanation of how very high level how like neural network work. That's the way I explain in my class as well. So hopefully that you can learn something from it, and so okay, all right. So now instead of doing this by hand, I could potentially use the formula to do that. I can do this very useful function called x looked up. So I could first I want to give a looked up value. I'm gonna look up the value and looked up is this token Christmas. And where do I want to look up? Where's the lookup array? The lookup array is going to again shift to the left. It's my entire vocabulary here. So this is my lookup array going down, going all the way down. So this is my lookup array. And what's the return array? Return array will be my word embedding. So it's here. This is my return array. So go all the way down. And then if I do this, you're going to give me this. And I know that it's the wrong orientation. So I can fix this to transpose. Okay. So I transpose this to the right one. Okay. All right. So now instead of picking up by manually, I can use a formula to do this. Look up Christmas, find the associated embedding, and put it right there. So I can do it for brain. It doesn't quite work because the reference got shifted. In Excel, the way to prevent it from doing it is that I want to fix that to the K column. So I'm picking up the vocabulary column, holding my vocabulary words. Similarly, my embedding is from L and P column. So I fix them so that it won't change if I copy over to the right. So let's remove this. Now I'm ready to copy over. Okay, so now I'm getting 3 column vectors. Now I'm do the first transformation is they go from 5 to 6. How do we change that from 5 to 6? That's what a neural network, linear layer does. Is basically somehow combine them in a way that they could get any arbitrary dimension you want next. So you want to go from 5 to 6, meaning that in this level you have 5 neurons. In next, sorry, 5 input, but in this level you have 6 neurons. You need 6 neurons to convert into a 6-dimensional vector. And the way the math works is that it's through a very simple multiplication. And if you just write math, you might see this math in your deep learning class. There's kind of wx plus b equals y, and this Excel allows you to visualize what exactly happening. So what's happening is that this is the matrix I map out. So if I want to transform from 5 to 6, I will have 5, 1, 2, 3, 4, 5. This is my 5 input, and 6 will be 1, 2, 3, 4, 5, 6. This is my output. So it arranged this way. So now I want to prepare this transformation matrix. I copy all the 0 over to initialize to 0. Okay, and then as a proof of concept, I'm gonna put the weight for the first location to be 1, and this weight is going to map to the first dimension in my input here. So this is the correspondence. Okay, so if this, I would expect that if after I multiplication, so I will get this number 0.828. So this should be 0.828, and this should be 0.036. This should be 0.842. Okay, that's what I expect my mass to be. And then let's try to implement this. So metric multiplication is quite easy for you to do. M mult, and now I can go select my first matrix over here. And then I select another matrix up here. This is my input. And the first matrix is my weight, second matrix input. Voila. Get this. This is actually hard to see. Is this 0.828? Let's just hide the ink a little bit for a moment. You can see that 0.828. Come on. 0.828, 0. So this is proof of concept is correct. If I do that, so if I move over here, you can see it's copying the second row. If I do that, so this is actually getting the value of third row. So if I do this, 1, 1, 1, it is basically summing the first 3 rows to obtain a new feature. Okay, so this is the intuition of linear layer. Let's bring this back up, my ink back up, and now in my practice, usually I just studied. Now I got the intuition right, so I just kind of randomly assign some 1, some weight, or maybe another 2 here. Okay, so just about some random way assign so that for my simple to work. And every time I do that, you can see those numbers change. Multiplication got revariated. Next, I'm gonna look at the how to add biases. So here, I want to add biases so that, for instance, this is 0.461, 0.799. I'd like to add 1, so everything kind of go up by 1. So I can put my biases here. How can we add that so that everything got moved by 1 over here? So biases is a good place to put this here. And then 0, 0, 0. I only add bias to my 4th location, or actually 5th location, my 5th neuron. And so the way to do it, I go back, update my equation. Maybe I just hide my ink right now. And then I add plus, and then I go to the left, and I select, actually no, not this, not what I want. So I use my mouse to select this column. So this is my weight column. And then you can see this number got moved by 1. So if I put 2, everything moved by 2, move by 3, 0 back to where we are, -1 go in the opposite direction. So this is no modification involved here. It's more adding the biases. Now this number looks scary, and this is my hand sketch looks kind of prettier, a bit less scary. Okay. Now next is activation function. What does activation function do is that I'm gonna bring this back again. So I would like to activate this neuron only if this value is positive. In this case, where these three values are negative, I like this to be 0, 0, 0. Let's just get back here. So this will be 0, 0, 0. Everyone else will be exactly the same number. That's what Redu does. And then, so to implement Redu, so one way to implement this, if this value, wait, no, I should implement here. If I can select so in I can select the whole block. If this is greater than 0, and then I will just select this block one more time, which would return the same thing. But if not greater than 0, which are negative, I set it to 0. So this is the equation. And voila, you can see that all the numbers are the same. Okay, but except for since they're negative. So I'm getting what I want. So there's a logic and philosophy behind Redu. Basically, take any positive number. So I have to go a bit quicker in my commentary. And the next step is that as you might see, the transformer, the core transformer uh is attention. So how can we add attention to it? So one way to approximate attention is that we could transpose the token into this way. And then when we do the combination, that will combining them across another dimension, across the position. So basically I can combine 1, 2, 3 position. We can get a new vector which is based on some combination of vectors from here. So this could be a combination of these three in some kind of attention weight matrix. So this is my attention weight matrix, which is also usually a square matrix. So I'm gonna do it very quickly now without a lot of commentary. So transpose, I'm gonna transpose this, pick up my speed, transpose this. Okay, and then I'm gonna have my attention matrix. So now if I have this I'm creating and this is no bias, and then I'm creating a dynamic matrix. So now I do a matrix location. Realize I'm talk too much. Okay, and then I'm going to multiply this. So I get this, and I'm gonna add my bias term. Go bias term, add my bias here. So this is my attention. Simulate approximately by didn't transpose. So there's a literature how you can run this NLP all the way. So there's a spirit behind this, and I can test it. If I add one, everything go by one. If I start to add more, let's just reset this. I want to show you if we just have identity matrix, there's no biases. This number looks like the same, just a transpose. But if I start to add more, so or this will allow me to combine them into a different way, add some biases. So there's a math behind it. But once we, then I could move, kind of transpose them back to this 3-column vector for my 3 words. And then I could run another linear layer to eventually get to my desired dimension. I'd like to move to 6 to 8 dimensions. I'll prepare my 6 by 8 matrix here, and also prepare my bias term here. And then once I do that, I can start to set some random ones, random weight values, or as this example. So when you train this network, you usually that's what you do too. You just start with some random weights, and then you run back propagation to update those weights. Now I want to do my matrix multiplication. Select this. Okay, and then also then select this, and then add my bias. So this is my linear layer I just implemented. This is my linear layer, my final linear layer. But we still have to find a way to combine them into one vector before I can output. So to do that is that I will use this transpose trick, transpose them into another orientation. And then I can combine them. Instead of just 3 to 3, I want to be 3 to 1. That's only one row of weight. So if I do 1, 1, 1, 1, what does it do? What it does is that if we do just 1, 1, 1, 1, it means I'm combining them with equal weight, all of them. So they will give me exactly the same result as summing them over, adding them up. Then add another bias term here. Okay, so I forgot to add select. I want to select this, select the, as my second matrix to multiply. Okay, so now if I do this, is you can test this. It does moving my value, and then eventually transpose back. So I got the form I want to output. So this is my sentence embedding, but it's not normalized. It could be like every arbitrary weight, and so typically I normalize so that by using the LO2 norm. And the way to get LO2 norm is we can add them up, but I want to add the square of each of this number up. So I do a sum square. So sum square. So we have a, for instance, 1, 2, 1, right? And the normal sum is just 4, but sum square is going to be 1, 4, 1, which is 6. So this is idea, sum square. And then I take a square root of that. That will give me a L2 norm. Okay, and then mathematically, basically, then you take this something square, so L2 norm. Okay, and then once you have that, I could take the whole vector and just weight them by normalize that by, then each one will divide it by this number, this value. And so we have this new vector, which is being weighted. And what's nice property about this, that if you calculate L2 sum of this number again, you get 1, add that to 1. So I have a, and then if you do that, I see I have some space for the column vector from for other chunk. They will have the same size and also same length magnitude because of normalization, and make comparison a lot easier. You will see in the vector embedding. And while now we have this vector, finally we have a first word. What I can do is that I will and let's just do a split screen here. Now I can skip ahead to my right hand side. Oops, that's not what I want to do. I just this. Okay, here, go up here. So it's kind of moving around. So this is what I'm trying to find. Okay, let's just redo this. It's kind of confusing. Let me just do it one more time. So what I want to do is that I can now put into my vector database. Finally, have something to put in my vector database. My first data, first chunk, my embedding. Where's my embedding? Let's, okay, now this is where I want to be. I want my embedding, I want to save my embedding to be the vector I just calculate. So first, I can use a split screen so I could go find that vector. I split this. Now, why is that split here? Okay, I'm split from here. Okay, so now I scroll to the back here. Okay, so this way we were, and we scroll down. So this way we just compute, right? So what I can do is that I will set this to this guy. So now I put the embedding, but I realize this is not the right orientation. I go back to change the transpose. Okay, 10 minutes. Let's do fast enough. And then also I would like to, for that to have my chunk information, go back, what's my chunk? So chunk is here, okay? So now I go back here. I want to set this to chunk here, set the here. Okay, now what I'm doing is I'm storing this into my vector database in the table and then assign ID to 1. This is my first chunk. Ta-da, I just finished indexing the first one, and I can do that for the rest of them, which I'll do very quick. The reason why I can do this is that I can copy and paste all this calculation over and then get exactly the same result because we are going to share in this way. And before I can share where I do a little trick is that I have to modify my formula, but I fix the weight matrices, the columns, so I can copy them without worry about. I can reuse this weight for my weights and biases. So I'm gonna do it very quick without talking too much. So let me just do quick. Okay. done. Okay, now I have one more. I have two more I have to do. So I will fix this. Fix my column. Fix my column for my weight matrices and biases. Okay, and then just one more. Fix my column for my. This is my biases. So this is my weight matrix. So okay, now I'm fixed. Okay, this is the most fun thing. Now what I can do is that I could, for my second position, second chunk, let me make sure I select the enough column. All I have to do is now I just copy. Come on, that's not what I do. Okay, go here. Copy. I want to just make sure I select enough of them. Copy this. Okay, and then I come back here and paste them. Now, and then I would see almost like calculation is be copy, except that I have to provide the just make sure I select the right chunk. So I'm gonna do is that this is I'm gonna come back here to select my second chunk, which is here. Okay, now so you can see that all the calculation is inherited, but so copy, and we'll get a new set of vectors here. What did I just do? Oh, I accidentally typed something here. Okay. All right. And then I'll do the same thing for my third one. Because now select this. Then did I select enough? Yes. And then copy. And then copy it again. Good. Okay, now I can do 3 chunks, but I have to do reset the chunk text over here. Select my third chunk and come back here and select my fourth chunk, and then we reuse all the weights here. And then you can see, check the calculation. You can see that if I select my equation, see the equations, you see the weight matrices and also the input are being selected correctly. And then we'll get this more column vector here now. So now with that, I can go back to my database. I want to index all of them now. So I find the right location for me to do here. And I'll split the screen here. So then I'll be able to go back first. I want to make sure I copy all the chunk information here. Come on, maybe I should select go from here. All right, so my chunk 2 is here. So now I select my chunk 2 is going to be these 3 tokens. Is it right? Is that correct? No, didn't work. One more time. The chunk 2, select, okay, good. And then the embedding. This is, I hope there's a faster way to do it. Embedding, I'm gonna scroll down to copy this. This is embedding for second one. I forgot transpose to transpose. Okay, and now it's copy here. And okay, it doesn't work. Okay, let's do one more time. Since I'm here, I might just do equals transpose. And select this. Okay, done. Equals transpose. And select this. So what I'm doing is indexing. Now I'm inputting all the embedding for these 4 chunks. But let me just go back here and to select the chunk text. So I can put the chunk text back in the database as well. So when I retrieve, I have access to the chunk text. And then if you are familiar with RAG, that's what you do is then you can put this chunk text into your prompt to provide some extra context. Okay, now I'm done. Finish indexing this 4 chunk into my database. So I still have time. Great. It'll be rushed, but now I can talk about query. Suppose now I have a new query. What do we do with it? So say I have a query, say joy, love, and joy. So this, if you look at this, it's kind of similar to this one, joy, love, and or Christmas bring joy. So how do we look it up so that compute the similarity value with respect to each of this chunk already in the database? So what we can do is hopefully, and then so I will do similar copying and paste here for my query. Okay, I select enough of this, and then copy over here. But now instead of copying this chunk from earlier, I can just set the chunk to be this query. Okay, now reusing my sentence transformer I just built, and then I have this new embedding vector. Now I go back to the database here. I can put this in this strategic location. I'm gonna tell you why I do that. So I can select this. Then this query is over here. Okay, now I have this query embedding arranged this way. Because if I arrange this way, I'll be able to do is I just do a metric multiplication with this. For all this embedding and then with this query embedding, metric multiplication, because the fact that we already normalize them is this number is actually cosine similarity. You can see that quite similar because we have a random embedding, but in practice it shouldn't be this close. But just as proof of concept, why do joy, laugh, and which is exactly the same as the second chunk. So you can see this value become 1. Okay? So in cosine similarity value, the most similar, identical, you get higher number. So when we like to get a top k, say 2, how do we get a top k? And we like to go in the particular direction. We want to go descending order, which means that we want to put the highest number at the top and go down as we go. So now we could basically do is we can now sort by function. So I want to sort my array with my ID and chunk. This is my database. The database information. But sort by, now I can sort by my cosine similarity values, which are score that calculated by with cosine similarity with embedding. And then this is the most important decision you have to make. Is it descending or ascending? I just talked earlier. This is descending. So I'm gonna do descending. So like this one is -1, and then do a descending of then while sorting this. So joy, laugh, and which is exactly the same as my query right now, is ranked as top 1. And Christmas bring joy because of joy is top 2. It makes sense. And then at the end, I can add. I only want to take 2 of this. So implement my top 2. But in practice, you will sort millions of record and take like top 2, top 5, etc. But right now, I just take top 2 out of 4. Okay, so this is completed my the whole thing going from, as a little review, what I have managed to do is that we go from training embedding, get word embedding, and chunk them into individual chunk and run them through vector embedding, somehow take you through the math of a very simple transformer with both the linear layer, also attention, very basic attention mechanism, and summarize into a word embedding, sentence embedding with one vector, putting into the database. So one thing and then be able to compare them by taking the dot product or metric multiplication between each database embedding over here and also query embedding, and able to rank them over here. And you can play with it. Like for instance, I can do joy, so it can get updated. It's all updated live and get different chunks. Okay, so I managed to finish. I'm quite happy about this, and almost all of you are still stay. Thank you. So I could answer questions. I have 5 minutes for question.
So, hi, we are officially starting with the Q&A session. So, thanks everyone for sticking around. And Akmal, is there any question that you would like to just
Yes,
highlight?
there's a couple of questions there, Yukti, which I left. So there was and I apologize if I wasn't paying attention, and maybe the person that asked it could clarify it. So the first question was from Akib. He was saying, and this is directed to you, Tom, why are you increasing, sorry, I think it's increasing and decreasing dimensions again and again. So
Also, in this case, in general, we are increasing. We did not decrease.
Okay.
So we go from 5 to 6 to 8. But the 3x3 here is a attention layer. I should write down attention layer, and we'll achieve this by transpose, so that the features are arranged by positions rather than by feature dimensions. And then we rerun this attention matrix. It will accomplish the purpose of attention. And then you transpose back, and you finally still run the linear layer. So in this case, it might look like we are changing dimensionality, but it's more about changing orientation for attention versus features. Hopefully, but yeah, just because it's just to give you some intuition of the different way of combining features.
There's a question here from AJ Tom who says, what does the overlapping word across every chunk with a different vector number indicate?
Overlapping word across every chunk with a different vector number indicate.
Yeah, I'm not sure if that's clear to.
Okay, so if the question will focus on overlapping, but sometimes a chunk, what if a phrase, for instance, Santa Claus, you happen to break the chunk right between these two words, so you cannot capture Santa Claus together. So overlap allow you to cross. You don't have a hard boundary of your chunk. And chunk typically, because it's limited, just because that you want to use a very quick sentence embedding with a sentence transformer with fewer. For instance, you have 128, but you have a really long paragraph that is your each document is say 4,000 words. So you just have to have 30 to 40 chunks. You are forced to do it because you can only fit 128 at a time.
Great.
If this can be done with Excel, it can be done with Google Sheet. Yes, all the calculations can be done in Google Sheet, except that you cannot sketch like the way I did.
Yeah, yeah.
Why
I
is it
think
called a sentence transformer? Because a chunk is a more general term of a set of words. Sometimes a chunk could contain multiple sentences. But if you ignore a period and commas and just consider a string of words, it looks like a sentence. And sentence transformer is like a branding that's from like Tom. He's a creator of sentence, not me. The other Tom, he make the sentence transformer popular. So I just use sentence transformer. Maybe you know it.
Tom, great feedback for you. I think lots of praise for the example of using this spreadsheet. It seems to have helped many people. They're very happy with this because it's a unique, never seen this before. And what it shows is that using a simple spreadsheet tool like this. I mean, you're using Excel today, obviously, but and I mentioned this in answer to some of the questions that yes, there are plenty of other spreadsheet packages out there. Many of them provide compatibility or similar functionality to Excel, and you could equally use those as well. That should hopefully work too. One particular question that came up time and time again, Tom, is people wanted the actual copy of your spreadsheet solution there. I don't know if you can provide that. I know you've got the blank one on your website, which they can do and fill in by hand, but I think they're looking for the end product of what you've achieved there.
Okay,
That's
yeah, so I'll
entirely up to
share
you to
this.
provide.
I'll post it together with a video because it's live stream. The video will become available
Yeah.
right away.
Awesome. That's great. So that will hopefully make lots of people happy there.
Okay, so I'm glad I did not fail spectacularly. I was somehow finished on time. Thank you.
Okay, great. So I'm just looking through. Let's just see what we can do. I think we're almost at the top of the hour, Yukti. So, yeah, I think a couple of questions on the the practical use of this, Tom. I mean, my response there was that what Tom's trying to show is that you can just take a simple tool, and yes, I mean there's a little bit of effort involved, but in terms of the formulas that are built in, you could utilize those, and you can do this by hand, and that's what you're trying to
Yeah,
show.
so it's great learning tool, just like a whiteboard. What's the practical
Yeah.
use of whiteboard? You'll never really run a rag to the whiteboard. It's a learning tool, but there's a kind of sitting between the bridging your PyTorch implementation of the whiteboard, because I can still sketch like a whiteboard as a professor, but also do a live calculation for you. You can see that it could be calculated. And so that's something yeah. But then attempting to build this live is the first time. And
Yes.
I'm glad that when I pitched this idea to Yukti and Akmal. They said, sure, why don't we try this? And I have a great time. I hope that if you have some idea of other topic you'd like to see in this presenting in this format, feel free to let me know.
Yeah,
Let us know.
great. Thank you very much again, Tom. Yukti, I'll come back to you because I realize we're at the top of the hour and it's actually very late for you in India as well. So you probably want to get to bed and get some sleep.
It's
So
all right. We actually, these webinars are much more fun because what else would I do? Like, I'll probably watch Netflix. At least I'm learning something. That's the thing. So, thanks, Tom. This was a very informative session, and thanks everyone for attending. And if there's anything that you still want to know, like if there's anything that you want to know about Single Store or uh, anything related to the session, any feedback, anything else, feel free to connect with me on LinkedIn and or even just send me a email. You can respond to the follow-up emails and we'll get back to you. And yeah, thanks Tom for joining. And this session was really informative. I'm actually looking to repeat this topic. Maybe we can actually write a blog out of it or something. So this was really interesting. And thanks everyone for attending. And stay tuned for our future webinars. And Akmal is going to do so many sessions. I'm so sure that everyone would be like, interested in joining those. So check our landing pages for that. And we regularly email regarding those as well. So if there's anything, feel free to RSVP and I hope to see you all there. And thanks again, Tom, for putting this amazing presentation together. And Akmal, thank you so much for your time. And thanks to all the attendees and have a great rest of the day. Take care, everyone. Bye bye.
Bye bye.